Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study about dipole moment. So in order to study about dipole moment, we must know about what are polar covalent bonds. First we will study about polar covalent bonds. That what are polar covalent bonds. So whenever covalent bonds are formed between atoms of different electronegativity. For example, let us discuss the bond between HF, hydrogen and fluorine. So one electron is given by hydrogen and one electron is shared by fluorine in order to make a covalent bond between them. But as we know, fluorine is more electronegative as compared to hydrogen. So electrons get shifted towards fluorine. As a result, what will happen? This fluorine atoms develops a partial negative charge on it, and the hydrogen develops a partial positive charge which are equal in magnitude. As a result, we can say that the bond between them becomes a polar covalent bond due to the unequal distribution of electron between the atom. So this bond is a polar covalent bond and leads to the development of the dipole moment. Dipole moment is represented by the Greek word mu. So what is the dipole moment? Mu is given as the product of the magnitude of charge and the distance of separation between the opposite charges. Between the charges. So mu can be written as q if we represent the charge with the alphabet q and let r is the distance between them. So mu can be written as q into r or q into d. Sometimes this distance is represented by the symbol d. So we write d over there. So mu can be written as q into d or q into r. It is measured in the units of dBi. Measured in dBi. And the SI unit for the dipole moment, SI unit for dipole moment is Coulomb meter. Now how this dBi is connected to Coulomb meter? So 1 dBi, or dBi is also represented with a capital alphabet capital D. 1 dBi can be written as 3.33564 into 10 raised to the power minus 30 Coulomb meter. So this is the relation between the dBi and Coulomb meter. Now how dipole moment help us to figure out the shape of the molecules. So if we have a symmetrical structure of the molecule, its dipole moment will be 0. Dipole moment will be 0. For example, let us study about the structure of BeCl2. We know that the bond between beryllium and chlorine are polar covalent bond, but the magnitude and charges we represent the dipole moment with then cross arrow from the positive to the negative atom. So this is how we represent it, but they are in equal and opposite direction. So the resultant dipole moment comes out to be 0. We can take one more example, BeCl2. If we talk about the structure of BCl2 we have already done. We now discuss about BCl3. Cl3, boron trichloride. So boron is the central atom to which the 3 chlorine atoms are attached, and the angle between them is of 120 degree. But as the molecule is having a symmetrical structure, so as a result, the dipole moment of this BCl bond cancels out the effect of each other, and the resultant dipole moment again comes out to be 0. If we talk about the water molecule H2O, now the hydrogen oxygen bond is polar, but the structure is not linear. The structure is a bent structure. We can represent the dipole moment from the positive atom to the negative atom like this. As a result, the resultant dipole moment comes out to be in this direction.